In this video, we're going to continue our notes and examples on the first derivative test. So let's look at this example 7. So in this example, we're going to use the first derivative test to find all of the local extrema, that is the local minimum or maximums, for the function given. And then we're going to use a graphing utility, so a graphing calculator, to graph our function and confirm our results. So just a review of the steps that we're going to take. First, we want to find the critical values of our function. Then step 2 is we're going to test the derivative f prime of x on the intervals determined by those critical values. So I'll say test the derivative between critical values. And by that, I mean set up a sign chart, which we saw in the previous video. And then step number 3 is then determine the max or mins based on how the function is increasing or decreasing between the critical values. So let's go through these steps. So finding critical values, what we first need to do is find the derivative f prime of x. So please pause the video and compute that derivative on your own. And now let's check answers. So derivative of f, well, f is just a difference of two x's with exponents or power functions. So we can use the power rule to write the derivative as 5 times a third times x to the negative 2/3 minus 5/3 times x to the 2/3. So we can go ahead and clean this up. So we can factor out, we see there's a 5 over 3 or 5 1/3, 5 times a third in each term. So we can factor that term out here. So we get 5 1/3 times, now let's take care of this negative exponent. So negative 2/3. So that becomes, we rewrite that as 1 over x to the power of 2/3 minus x to the 2/3. All right, so there we have the derivative. So to find the critical values, we're going to test, oops, a little low on battery, that's okay. So to find the critical values, what we're going to do is determine if, or we're going to find those x's such that f prime of x does not exist or is 0. So there are any x values where this derivative f prime of x doesn't exist? Awesome, you betcha. Well, when x is equal to 0, that denominator is 0, so that function does not exist there. All right, so there's 1, keeping track of that. So where else? Well, we need to check then where our derivative is 0. So what we're going to do is check where 0 is equal to 5/3 times 1 over x to the 2/3 minus x to the 2/3. And I'm going to go ahead and make an extra page just to give us some more room to work this out. So let's go ahead and use a new page here. Awesome. All right, so it's really important to use a lot of room when you're working out your math and your computations. The more room, you can keep track of what you're computing and you can look back at your work. All right, so we're solving for x in this equation. So at this point, I encourage you to pause the video and try to solve that x for yourself. And then once you get stuck, start up the video and we can go through together. All right, so to solve for x here, we want to first get rid of everything else that's involved with the x. So we can first multiply both sides by 5 over 3 in order to get that 5 over 3 to cancel. Oops, is that what I want? Good catch, everyone. I'm going to multiply by 3 over 5. Notice then the 3 in the numerators will cancel with the 3 in the denominator, and similar with the 5. So multiply both sides by 3 over 5. So we get 0 is equal to 1 over x to the 2/3 minus x to the 2/3. So now I have an x term in each of these terms in my difference. So I'll go ahead and add x to the 2/3 over. So I have x to the 2/3 equals 1 over x to the 2/3. So now what I want to do is get that x out of the denominator here. So to do that, what I'm going to do is multiply both sides by something. What should I multiply by? I should multiply both sides by x to the 2/3. Because then when I do that, that term, x to the 2/3, will cancel the term in the denominator. So we have something like this. All right. So now the left-hand side then becomes x to the 2/3 times x to the 2/3. So I have the same base. So I can just add exponents. So I get x to the 2/3 plus 2/3 is 4/3 equals 1. So now I can take the cube, or rather cube both sides. So now I just get x to the 4th equals 1. So this means x could be equal to +1 or -1. And notice I'm figuring that out by taking a 4th root of both sides. And we just need to think a little bit about what that would become. So if we just had x as 1, if we took 1 plus 1 and raised it to the 4th, we'd still get 1. But if we also had a -1 and multiplied by itself 4 times, we'd also get +1. So that's why we get these 2 critical values here, or these 2 values for x. All right, so let's flip back to the previous page. So now we know we have a few more values here for our critical values. So we also have x is equal to -1 and +1. So we have those 3 values that are critical points. So that means our graph is going to be either at a local min, local max, or neither at those points. But that's where the important behavior of our graph is. So then now we're on to step 2. So step 2, we're going to make that sign chart. I'm just going to star that so we know where we are at. Sign chart. So what does that mean? Well, we're going to lay down our horizontal axis, if you'd like, or our number line. We're going to label it with those special critical values. And then we're going to test our derivative on the in-between points, or the in-between intervals. So I'm going to test my derivative. I'm going to say, I'm going to plug in a point over here, and I'm going to ask, what is the sign of my derivative? Because recall, the first derivative test, or what we know about derivatives, is that if the derivative is positive, that means our function is increasing because the slopes of the tangent line are positive. So we could pick a few values. So we could pick -2 we want to test. We want to test -1/2. We want to test 1/2, and we want to test 2. So what I'd like you to do is pause the video and evaluate f prime at the points that we've identified here at -2, -1/2, 1/2, and 2. And then above here, above this number line, I want you to tell me if the derivative is positive or negative. So please pause the video, and then when you're ready, we're going to check solutions. All right, so I'm going to give you the signs that I found. If you'd like more support in how you'd compute that derivative, f prime of c at these points, please let me know. I'd be happy to give you more detail. But at this point, I want to continue the video so that we can graph our function and confirm our results. And I also trust that at this point, you're fairly comfortable plugging in values into our derivatives or our functions in order to determine the value. All right, so what should we be getting together? So for this first interval here, I'm getting a negative value. Second interval, positive, positive, and then negative. So our sign chart should look something like negative, positive, positive, negative. So from this sign chart, number 3, can we determine if we have maximum or minimums at our critical values? So I always like to draw kind of a little cartoon sketch before looking at a graphing calculator to determine what's happening with my graph. So what's going on here? Well, negative means that our values or our function is decreasing. Positive means our function is increasing. Positive means our function is increasing. Negative means our function is decreasing. So that means our function looks something like this. So what do we think is happening at these 3 critical values? Please pause the video and try to determine that before continuing. Awesome. Okay. So here, as we see in my little cartoon, when our graph goes from decreasing to increasing, we have a local min. So we have a min here. When our graph is increasing and increasing, well, nothing happens, right? No local max or min. When our graph goes from increasing to decreasing, that's where we have a local max. So it seems to be that when x equals -1, we have a local min. And when x is equal to +1, we have a local max. All right, so now let's go ahead and graph this function to see if what we found is correct. So let's go over here to our Desmos graphing calculator. And recall, am I going to put in the derivative here or the function? The function, because I want to know, is the function min or max at these locations? So I'm going to plug in my function 5x to the power of 1/3 minus x to the power of 5/3. Okay, excellent. Here we go. So here's our graph. Beautiful. So let's look at what's happening at our graph here. So when we have an input value of -1, we see that we are at a local min. At 0, our tangent, our derivative, or our tangent line is undefined. And we see that has a vertical tangent line. So the slope or the derivative is undefined. Then we go over here to -1 input, we see that we do have a local max. So there we see it in our graph as well. Awesome. Great work, everyone. Thank you for watching.